Hello guys, welcome to my channel. In today's videos we're gonna discuss about binary search algorithm. So what does it mean by binary search algorithm? So binary search algorithm is definitely designed to as a superior version of the simple linear search algorithm. Now let's see what are the specifications that are involved in a binary search algorithm. So let's see. Binary search algorithm. Now what does this mean? That we have an array and we want to find a certain element in it. For that we use the binary search algorithm. Like, let's look firstly have a look at the procedure, so that you can just understand the procedure and then can implement it in any other programming language. Let's see what is the procedure for this algorithm. Okay, we will be having some input, which is of course an array, say a, and the number of elements in it, and x, the element that we want to find, and some other bunch of other numbers which we need to define in the language but not here in the algorithm procedure. Of course, output can be not found, like you just say that, hey, in this array there does not exist an element called x, that's it, or it can be some index. Okay, so the procedure for this algorithm, let me first write this, then I want to explain each of these steps. Just wait for a few seconds, otherwise. So let's see how this algorithm works over here. So number one step, number two step, and number two step is comprised of these many steps. Okay, so what does this mean? P is assigned 1, R is assigned n. What does this mean? We have an array. Okay, we have its starting location, that is 0, and the last location, suppose that it's n. We have P that is assigned 0, should be assigned 0, I believe. Okay, P is assigned 0, R is assigned n. So we start with the full array, then we check that P is less than equal to R, that we are just looking inside the array, not outside it. Then we do Q P plus R by 2. Then we take a number that is Q, add the two numbers, divide it by 2, and take its integer part only, not the fractional part, and then we divide that array at that point at Q. Okay, so moving on further, if we divide the array, now we have got a number Q. Suppose that we are dividing array at this point, that is q. If a of q is equal to x, if this is the number that we are looking for, then we just say return q. We are done. We have find the element and its index is q in the array. Otherwise, a of q is not equal to x. If it's not the element that we are looking for, then we check if a of q is greater than x. When we check that is this number greater than x, then set r to be this. If this number is greater than x, then we set r to be q minus 1 over here, that is one element less. Then we take that array, otherwise we take the other array. Okay, now let's see this again with a proper example. These steps I believe are not clear. We have an arranged array. That's the main point of this algorithm, that array is arranged in ascending order. That is the increasing order, arranged array. That's the main point to be noted about this algorithm. So we will be having an arranged array like 3, 5, 7, 9. So firstly we will do p to be 0 and r to be 0, 1, 2, 3. Okay, then we say q. Q is, then we calculate q. What will be the q? Addition divided by 2, that will be 1. So q is 1. So what we check? Then we check a of 1 equal to 5, which is not equal to the number that we suppose we want to look for 7. That is not equal to 7. Then we go to this step. If a of q, that is 5, is greater than x, that is this number, then set this. Now a of 1, which is a of q, is equal to 5. It's less than 7. So what we will do? We do this step. We set p to q plus 1. That is, now our p becomes q plus 1. Q is 1. 1 plus 1, that is 2. So our p becomes 2 and our q remains the same, that is n, that is this. So we will take this array then again and perform the same operation on this, and then eventually we will come to 7 and find out that its index is this one, 2. That's how the binary search algorithm works. Thank you for watching this video. Please subscribe to my channel.